So I'm going to show you how to do all of the stuff we're testing on the calculator. So the first two lessons we talked about univariate data. So I'm just pulling the notes up from 14.1, and I'm going to take this table, heights of classmates in inches, and I'm going to show you how to calculate mean, median, all that jazz, make a box and whisker plot, and all those things on the calculator. So if you have a calculator to follow along, that'd be fantastic. If not, you can just watch and you'll still figure something out. All right, so if I want to enter some univariate data, meaning I only have one variable, this is heights of classmates, not height of classmates and age. It's just one variable. I'm going to go to Stat, and automatically it pops up on Edit. I'm going to go to Edit. I'm going to enter my list, so 61, 58, 62, 60, 57, 67, 68, 61, 64, and 70. I like to double check my data, so I have 5 by 2, so I know there's 10 pieces of data. I can see that L10 or L110 says there's 10 pieces of data. And I like to just check real quick, so 70, 64, 61, 68, 67, 57, 60, Okay, everything's good. All right, if I want to just calculate the mean and median and all that stuff, I would press Stat. I'm going to go over to Calc, and I'm just doing one variable stats, so I'm just going to press one var stats, so press Enter. Okay, I'm just going to press Enter, 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 and that's everything I need. So on here, you need to be mindful that X bar is the average, SX is the standard deviation. Remember, average or mean is all the terms added up and divided by the number of terms. Standard deviation tells me how spread out the data is, so how far points are away from the mean. So mean and standard deviation go hand in hand. Those guys are kind of stuck together. If I have a mean, I have a standard deviation that makes sense. Okay, then I have what's called the 5-number summary. So it's got the min, Q1, median, Q3, and max. And if I want to make a box plot, these guys are all going to be in the box plot. We use these points as well. Max minus min gives me my range. Q3 minus Q1 gives me my interquartile range, or IQR, which I would need just to answer basic questions or to find outliers above or below. Okay, if I would like to make this data into a box and whisker plot, I'm going to have to press second stat plot. So second stat plot. It's going to pull up all these plots. They should all be off. If one of them is on, it's probably okay as long as it's the first one. So I'm going to press Enter. I want to turn this stat plot on. Okay. We did learn the last couple days how to graph scatter plots, so we're going to skip that for now though. I'm only doing univariate data. I only have stuff in list 1, so I can't do a thing that has things in list 2. So I'm going to go down, I'm going to press over until I get to that middle box and whisker plot. I'm going to press Enter. That's going to drop me just to list 1 instead of having 2 lists. And then I'm going to press Zoom 9 to actually graph my information on my plot there. So I'm going to press Zoom. You can actually go down. It's called Zoom Stat, but you might as well just press the number 9. So I'm just going to press the number 9. Boom. And there's my box and whisker plot. So if you need to graph a box and whisker plot, put your data in. So Stat Edit, put your data in. Again, go to Stat Calc. You can do all of your var stats, all that jazz, get that information. But in order to actually graph it, press Zoom 9. All right, here's my box and whisker plot. If I want to know what those points actually are, because I've forgotten what they are, I can press the trace key, and then I can actually see. I have min, Q1, median, Q3, and max. Don't forget, 25% of the data is in that section, 25% is in that section, 25 and 25, which means 50% is above and 50% below. So that's how you find most of that data there. You can't find mode on the calculator. You just got to look at the data yourself and know the mode, but most everything else you can find on the calculator. All right, so next we're going to talk about what we did in lesson 14.3 and 14.4, which is our bivariate data. So I have example that has 2 variables. I have the frame size and the inseam length, whatever that's standing for, doesn't matter. But I have 2 variables. So when I go to stat, I'm actually going to have 2 lists. So I'm going to go ahead and clear my calculator out, second plus 712 to clear it out. I'm going to go back to stat, I'm going to go to edit, and I'm going to enter all of these guys in. Okay, list 2. And I'm just going to double check. So I'm looking at my list as I double check. Oops, went too far. Okay, I think it looks good. All right, and then we learned how to do a linear regression in chapter 14.3 and quadratic and exponential regression in chapter 14.4. So I'm just going to show you how to do both of those. So first things first, if I've graphed 2 pieces of data, so an x and a y variable, I would go ahead and just actually graph those things. So to graph, I'm going to press second stat plot, and now because I cleared my calculator, it's off, but you may have had it still on if you didn't clear. I'm going to turn it on, and I want to make a scatter plot, so it's automatically highlighted scatter plot for me. Also, I have an L1 and L2, so I know that's correct. If you wanted to, you could actually go change your dots or whatever if you wanted to. That's totally fine, but there's no point in doing that. I'm going to press zoom 9, and that's going to graph it for me. I would always graph your dots first to know what the shape is. I see it looks pretty linear, so when I go to my math, I'm going to do the linear regression. All right, so to do that, I'm going to go back to stat, and I'm going to go to calc. And I'm not doing one var stats anymore, so I'm going to go down to linear regression, so linreg, number 4. And I'm going to show you a couple different things, but I'm just going to go ahead and boom, just get my answer. So it's linear. If I were just looking for the equation, there's the equation. So you press stat, calc, linreg, and just press enter, enter, enter. That's going to give me just my equation. But I want to do more than just that. Most of the time, you're going to want to actually graph that line, and you're going to want to find the correlation coefficient. I'm going to go ahead and graph it first. So if you want to actually store the equation in your calculator, do linreg. But when you get down to store regression equation, you're going to go over here to vars, and you're going to go to the right and get y vars. So press the right arrow key, get y vars, y variables. And I want to do function, so I'm going to store this as a function in my calculator. And I want to store it in y1. So I want to store under the y equals, so store under y1. So press enter. Again, so I'll do that all again real quick. So I did stat, calc, linreg, enter, 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 whatever. I get to store regression equation. I press vars, press over, press enter, enter. And then I'm just going to go down to calculate, and boom. Looks like the exact same screen, but now I've actually done the math, and it's actually stored it under y equals. So there's my equation. To see that, you can just go straight to zoom 9 though. And now it's going to graph my line on that regression there, or on those dots, my linear regressions there. Okay, so the things we're going to ask you to do on the test is I'm going to give you some data. You're going to put it in. I'm going to say, what is this? And you're going to graph it and say, what is that? Well, those lines, those dots look like a line. You're going to go to stat, you're going to go to linreg, and you're going to actually graph that guy and make sure your equation is correct. So there it is. And we've done it several times already. And we'll do one more example as well. Okay, the last thing that only applies to linear regressions is the correlation coefficient. So I want to know how closely related to this line these points actually are. So in order to do correlation coefficient, and you could have done it from the very beginning, but you only need to do it when I'm asking just for correlation coefficient. I'm going to go to mode, and you can go all the way down, but I like to just press up to get there a little quicker. And I want to go to stat diagnostics, and it's currently off. I want to turn it on. So stat diagnostics, and go ahead and turn it on. It's going to run the diagnostics of this line that I just created. So I've turned it on. So now when I run my linear regression, it's going to give me my correlation coefficient, 0.985, blah, blah, blah. 0.985, or actually 0.986, is very strong. Anything in the 90s, the 0.9s or negative 0.9 is going to be pretty strong. But this guy's very strong. If I look at my graph, I mean, I can see that these points are very, very close to the line. This guy's a little bit out, but for the most part, he's pretty close. So 0.986 or whatever it was is your correlation coefficient. Okay, so that's when I told you it's linear regression, and I told you what to do exactly. The other case is if I don't know what to do exactly. So I give you a piece of data, and I don't know what it is, whether it's linear, exponential, quadratic. Okay, so I'm going to go ahead and second plus 712, just because this might be the first question during the test. And also I want to point out that when you do years, you're going to start out at 0. So let me move this head away. The reason being, if you put in 1910, which you could do, but then the calculator is going to try to go back to year 0 to find your population, and it's going to give you a major negative number. So it tries to extrapolate the equation back, which doesn't make sense in these problems. So just start with whatever year you're given, and then just work up. So 10 to 20 is 10, and just count up. 50, 60, and 70. So 1910 is my starting year. That's 10 years later, 20 years later, 30, 40, etc. Okay, so when I go enter my stats, I'm going to go, get it right here. I'm going to go to stat, enter, and I'm going to type in 0, 10, 20, 30, 40, 50, 60, and 70. I'm going to type in 21.2, 24.2. Uh-oh, I got off somehow. Blast. Okay, so boom, 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 boom. Oh, I got 32.3, 31.4, and 30. Oh, 30. Okay, again, always double check your data. It's really easy to make a mistake, especially when you've got decimals and stuff. All right, I recommend graphing it first just to get an idea. So I'm going to turn my stat plot on. So second stat plot, turn it on, and then zoom 9. That's going to get my graph. Well, that's going to give me a good idea of what it looks like. I don't exactly know what it is. I mean, clearly it's not linear, but maybe it's exponential, maybe it's quadratic. I mean, it kind of looks quadratic, but I'm not 100% sure. So let's say that we think it's exponential. I'm going to go to Stat, Calc, and I'm going to go down to XReg, exponential regression. Oops, too far. Exponential regression. I'm sorry, I keep pressing random buttons. Exponential regression, right here. And when I'm going to go look at my equation, I have to store this guy so I can compare the line on my graph. So I'm going to press vars, y vars, enter, 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 and then I'm going to press zoom 9. Now I can see my exponential regression on my graph, and I can see that it's clearly not working. Like the calculator is doing the best it can to make this equation work, and it is not working. So clearly not exponential, clearly not linear, it must be quadratic. So I'm going to go back to stat, I'm going to go to calc, I'm going to go to quadratic regression number 5. I'm going to go down to store, and I'm going to push vars, y variable, enter, enter, enter. It's going to give me my equation, so if you want to, you can go ahead and write your answer down, but I'm going to double check that the quadratic is as accurate as I can get. And he's not perfect, but he's definitely way better than the exponential, and linear would definitely not work. So this guy's definitely quadratic, and I didn't write my equation down, so I just go back and do the math again. My equation would be y equals negative 0.006 x squared plus 0.546x plus 20.89. Like you just write your equation and then it's there. That's all you need to know, I'm pretty sure. So be able to do one variable stats where I just put in one list of stuff and I go to stat, calc, and I do one vars, or put in 2 variable statistics and then you got to decide, is it linear, is it quadratic, or is it exponential? And you can't ever really just be sure unless you actually choose it and store that equation and graph it. You have to be able to look at it and see, I chose wrong. This is definitely not exponential. I need to choose the other option. Once you know what it is for sure, then you can easily just go back and run the correct thing. So I know it's quadratic, and I can just run it and then just get your equation. I may ask for slope or intercept or things like that on a linear regression, or I may ask for what's the starting value on a an exponential. If your exponential is like y equals 0.257.18x or whatever, I can say, what's the starting amount? Well, that's 0.258. What happens each time? Well, it's multiplying by 0.18 every single time. So you should be able to answer questions as well from the equation that you figured out. Also, don't forget that when you're doing this, you can do your table shortcuts. So remember, linear should have fairly same differences. Exponential should be multiplying by fairly the same number each time. And then quadratics, where you do all these differences, and then you do the second difference. And these guys should all be roughly the same. Okay? All right, good luck.